turn this into this. Lombok just has to be the most effective way to write Java code, which is why I include it in every Java project I write. So Lombok is a Java library that generates boilerplate code for you at compile time, and you can control which boilerplate code is generated by using the corresponding Lombok annotations. Annotations exist for getters, setters, constructors, toString, and probably a whole bunch of different things you're currently writing by hand. And better still, it integrates so well with your IDE. We're going to be showing it off in IntelliJ today, and that's the free version. There are a ton of solid gold features in Lombok, and we'll make our way through them. But stick around to the end because we're going to explore some of the more controversial ones then. I put some code together to allow us to test out some Lombok features, so let's start by grabbing that from GitHub. So let's grab the code from GitHub. First thing you want to do is open up a browser and go to this URL here, and it will bring you to the GitHub repository. Now you'll see we've got different modules for different states of the project, and we'll go through each of these in turn. But if you wanted to jump to one of them, then you can go ahead and just open up one. If we take a look at the first one here, this is the example of a Java project, plain old simple Java project that doesn't have Lombok installed. And that's where we're going to start. So if you want to download all of these, what you'll need to do is go to the code here, get the URL. If you're using GitHub for desktop, you can choose to use that tool, or you can download it as a zip file if you want to do it that way. But if you grab the URL here, we'll open up a terminal, and then we'll type git clone and then the URL. And this will clone it to the current directory that you're in. If you don't want it in that directory, then navigate to a directory you do want it in, and then hit enter, and it will clone that down. And all that's left to do is open that up in your IDE. So here we are in IntelliJ, and you can see here I've decided to open up the project from the no Lombok directory because that doesn't have any Lombok, and that is a great place for us to start. So now a very quick tour of this project. So we can see here we're using Maven as our build tool. We've also got the Maven wrapper that goes along with it. So if you don't have Maven installed on your system, you can use the Maven wrapper, and we'll use that in a moment. We can take a look here in our dependencies file for Maven. We have Jackson, so we're going to be using some JSON or Java objects to JSON and maybe back again. We'll see. We can see here we're using JUnit 5 for some tests. We've got the AssertJ Fluent Test Assertions library in there because it's just lovely. And yeah, we're just pinning some versions, nothing too special in there. Oh, and we are needing a Maven version of 3.9 or greater, but as we're using the Maven wrapper, that should be absolutely fine. So we'll run Maven by using the Maven wrapper. So this is MVN-W, that one for if you're on a Linux, Unix-like system. And this one, if you're on Windows, the CMD. And we're simply going to type test, and that's going to compile for us, and then it's going to run the tests, of which we have a few. Okay, so we can see that we've got 14 tests run, and it's a build success. So that is the first step. We have a nice working sane project. Let's dip into it a little bit further. So we can see if we dip into the source code, we have app here, and all that app does is it creates an object mapper. So that's the thing that converts from JSON, string JSON into Java objects. And we can see we're reading in a file, which is bookauthors.json, and we're simply going through each of the books that we pass from that JSON file, and we're printing it out. If we take a look at the domain objects that we have, we've got a public class author. So this is modeling an author, and we can see we've got a given name, a family name, and an age, typical with a person. And we can see that we have a no arguments constructor, we have an all arguments constructor, and we have getters and setters for each instance variable. We have an equals, which I didn't write, is implemented by my IDE. Thank you, IntelliJ. We've got HashCode and toString, which again is largely generated for us. And the book's pretty similar. So we can see that the book has a title, a year published, and then a reference to the author. And it's exactly the same in terms of having a no arguments constructor, an all arguments constructor, getters and setters for each instance variable, an equals, a hash code, and a toString. If we were to perhaps take a look at that JSON file, which we have sat in resources here, we can see that we've got a JSON array of book objects, which also reference an author here. So the first one being the Enigma of Eternity. All of these are made up, by the way. And we have a year published 2005, the given name, Aria, family name, Montgomery, and age 36 of the author of the book, The Enigma of Eternity. And there's a whole bunch more in here as well. So if we want to run this application, we'll simply go to our app here. And because we're using IntelliJ and it's awesome, we'll click on run. That's going to build the project for us, and then it will run. And we can see here it's simply gone through each of the books in that JSON file, and it's printed them out. The Shadow's Whisper, the Sorcerer's Stone, the shattered crown. So we've gone through the source code, we've run the application, but I'll need to show you these tests because that's where the magic's going to be for the exercises we're going to do today. So if we open up the test directory here, we can see that we've got 2 test classes, and then we'll get onto test data util in a moment. So if we look at author tests, this is something you typically wouldn't do, or something that I wouldn't do, is try and test just a basic Pojo. But by adding these tests, when we swap out some of the code that we've written for Lombok annotations in future, you'll see that everything will continue to run smoothly. So we've got tests here for the no arguments constructor and the all arguments constructor. Technically, these wouldn't ever fail because, well, if we don't have a no args constructor or an all args constructor, we'd get a compilation error rather than a failed test, but it still demonstrates the point. And then we've got tests for the getters and the setters here. So give a name, family name, and age. And then we've got a test for the equals, making sure that if we create 2 authors that are exactly the same in terms of their attributes, that we consider them exactly the same via the equals method. And then we've got a test for our toString. I won't bore you with the details, but the book test follows exactly the same format. And very quickly, the test data util is just a utility class. So you can see here, it's got a private constructor, which means it cannot be constructed. And it's got just 2 static methods on there, one that creates a test author and one that creates a test book. And I use these throughout the test just so we don't have to copy and paste these chunks of code each time. So that in a nutshell is the application that we're going to be using today. So let's get started and install Lombok. So let's install Lombok into our project. So first thing we need to do is open up our POM file here. And if we take a look, we've got some dependencies, we've got some test dependencies, and then we've got the production dependencies, I suppose. So I like to put Lombok in the production dependencies. So we'll just paste in this block. Now I'll put this block inside of the README file, the top level one, so you can just copy and paste it. And I'll show you a nice little trick to make sure that you have the most up-to-date version of Lombok. So first things first, let's just explain this. The group ID and the artifact ID, pretty obvious what they do. They identify Lombok. The version is just the version of Lombok. Again, no surprises, no prizes for that one. But this scope provided, you might be asking some questions about that. So what that means is we'll use Lombok at compile time, but we don't want Lombok in any of the things that we build. So if we just had the default scope of compile, then we would have Lombok at compile time, absolutely, but then it would be bundled in with the artifact that we build and deploy. And you know what? It provides no value at that point. Lombok does all of its magic at compile time. So provided is really used to say that this dependency will be provided by either the JDK or some kind of application container at runtime. But as it's actually not used anywhere at runtime, this is kind of a hacky way, I suppose, of saying have it at compile time, use it at compile time, but don't include it in the built artifact that we then run at runtime. And just like that, we have the Lombok plugin installed. How do you make sure that we have the latest version of it? Well, we could go online and we can check the Maven repositories, but here's a quicker way. We would open up a terminal here and we would run the Maven versions plugin here. And we're going to say Maven versions use latest versions. And when we run this, it's gone through all of our dependencies and made sure that the versions are the very latest. It just so happens that 1.18.28 is the latest version. I just like to keep things nice and organized by extracting out lombok.version into a property that now lives up here, nice and organized, and away we go. So a lot of the later versions of IntelliJ already have the Lombok plugin bundled along with it. But let me show you how you check for that, and if not, how you install the Lombok plugin. So let's make sure that IntelliJ has the Lombok plugin installed. So we'll go to the settings by clicking on IntelliJ up here and then clicking on settings. I'm obviously on a Mac. If you're on Windows or Linux, you would have to go to the various place where that settings lives for IntelliJ. And we'll want to go down to the plugins menu here. Now we've got 2 little tabs. We've got one for Marketplace, one for installed. I want to see if Lombok is installed. So I'm going to go up and then in the search, I'm going to type in Lombok. And we can see that we've got Lombok, it is installed, and it says that it's bundled. So it comes along with the later version of IntelliJ. This hasn't always been the case. Now you might find that you don't have Lombok here, in which case you'll want to go over to the marketplace, type on Lombok, and you'll need to find the Lombok plugin. Remembering it looks like this, but it will be over here. and you'll just want to click on the install and you'll get Lombok. Obviously, I can't do that because Lombok is already installed, but you get the gist. So we have the Lombok plugin installed. What do we do now? Well, let's use it to replace some getters and some setters. So let's use Lombok to replace some getter and setter code. Now, getters and setters are a great idea. They encapsulate all the logic of getting and setting from an instance variable so it can be tweaked in future. They play nice with all sorts of libraries like Jackson for JSON and even Lombok itself. They help with mocking, making lambdas look prettier, and all sorts of other things. But they are a pain to write. And I don't know about you, but 99% of the time, they are the plain vanilla version that looks a little bit like this. So let me show you how to use Lombok to replace all of this getter and setter code. There are a couple of ways of doing this. We can either put our Lombok annotations on the individual instance variables, or we can put it on the class in order to cover all of the instance variables in that class. But just to prove that what I am showing you actually works, let's just run our test for this project first, so I can show you that the changes still allow the project to work correctly. So I'm going to go over to my tests here, right click, run all tests. There we go, and we can see that all of our tests are green. Wonderful stuff. Let's minimize that. So we'll go up here and we'll do this in the author class, I think, the instance variables. And I'm going to type @getter and @setter on the top of the instance variables here. Now, it looks like we aren't able to import these. Otherwise, I would have got this highlighted already. So I'm just going to go over to Maven here, click on our project, and then click on this reload Maven project, just to make sure that the project in IntelliJ is up to date with the dependencies that we have in our POM file. Okay, that looks like it's completed. So we'll go back down to getter and setter here, and we can now import these. Wonderful. Okay, and we'll do the same for family name, and we'll do the same for age as well. That's looking good. Now I'm going to go ahead and I'm going to remove manually these getters and setters. And it's as easy as that. So I'm just going to run our tests again. Enable annotation processing. There we go. And we can see that all of our tests are now passing using the getters and the setters generated by Lombok. So you might be thinking that's a lot of hassle. I want getters and setters on all of my instance variables. And I think you mentioned you can put it on the class. You absolutely can. So let's go over to the book and I'll show you how to do it there. So this has title, year published, and author as instance variables. Now what we can do is on top of the class here, type @getter, @setter, just import that. And this will apply getter and setter annotations to each of the instance variables in this class. So if we go down here and we remove all of these getters and setters, and now we run our tests, we can see that again, all of our tests are passing. We're using the getters and the setters generated from Lombok. And you might be saying, Aaron, isn't there a quicker way of doing this? And there absolutely is. So let's just undo all of our changes to this class. There we go. So no getters or setters on this class anymore. Let's just run the test to make sure everything's fine. Looking good. So what's this quicker way? Well, what you can do is you can right click, go to the refactor tools in IntelliJ. And if you scroll down to the bottom here, all the way down, you have these options of Lombok and deLombok. Now, Lombok allows you to add Lombok annotations in place of the code that you have in your class already. And deLombok does the opposite. It replaces Lombok annotations with that generated code. So we wanted to use @getter and @setter. So I'm going to say default @getter. I'm going to go again and go down to the bottom here and go Lombok, default @setter. Perfect. So that's imported them. They'll be applied to each of the instance variables. But then we've also got each of the getters and setters that we wrote removed for us automatically. So if we run a test once more, we can see that everything is working absolutely fine. And that was a quicker way of getting our getter and setter annotations on our class. If you've used an IDE like IntelliJ for any length of time, you know that it can generate code for you. Code like getters, setters, and constructors. So we're using Lombok to replace this code. Is Lombok really that much more valuable than just having your IDE generate this code for you? Why bother using Lombok at all? Here's why. Because the code generated by your IDE lives in your code base. So it must be checked in and then manually updated every time you, I don't know, update a variable name, for example. Now, I know what you might be thinking. Aaron, the IDE has tools to help with that, like the refactor tools, which allow you to change an instance variable name and have the getters and the setters method names updated as well. And I know IDEs like IntelliJ are really powerful with the refactoring tools and make things really easy. However, Why bother going through all of that hassle if you don't have to? So the annotations like the @getter and @setter annotations for Lombok, they generate the getters and setters at compile time. So if you change your instance variable name, that's absolutely fine, because the getters and setters that are generated will use that new instance variable name because they're generated at compile time. No having to retrospectively change code, because it would just be generated afresh for you and it will always be correct. So saving time and brain cycles is the biggie. But if you're anything like me, you don't want your IDE screen cluttered with a whole bunch of junk code, which doesn't have to be there. So that's getters and setters. Let's now tackle constructors. If you found this useful so far, be sure to subscribe so you don't miss out on new free courses just like this. So getters and setters are easy. What about constructors? Well, we're back on our author class now, and we have two different types of constructors here. We have our no arguments constructor, and we have an all arguments constructor. Now, no arguments constructor doesn't take any arguments. The author all args constructor here requires a given name, a family name, and an age, which is just set to the local instance variables. And that's for every single instance variable available in this class. Both of these, fairly common. So what can we do to replace this code with our Lombok annotations? Well, it's one Lombok annotation for the no args constructor and another for the all args constructor. So what we'll do is go up here to the top of the class this time, and we're going to type @no args constructor. And that will allow us to then remove the no args constructor, and that red underline goes away. Let's just run our test to make sure everything's fine. Looking good. And then we'll do the same for our all args constructor. Again, that red line signifies that we already have a constructor with 3 parameters defined. So let's remove it. And there we go. Just like that, we have an all args constructor as well. Let's run the tests. Everything's working absolutely fine. So that's the author class done. Let's do the same for our book class. So I'm just going to copy these 2 annotations, go over to our book class, go to the top here, and we're going to place these under the getter and setter annotation. And we're going to remove the all args and the no args constructor that we've written. And let's just run our tests. Looks absolutely fine. Everything's green. So you might be asking, why did I not use the Lombok refactor tools in our IDE? Well, if we take a look at them by going to refactor here, all the way down to the bottom, going into Lombok, we don't have an option for constructors here. However, if we did go to dLombok, which does the opposite, so it takes the annotations and then converts them into generated code, we do have one for constructors. So if we click that there, we can see that we do have our generated code back once more, and we have the annotations removed from the top. So that's an interesting little quirk. So we're just going to undo this, run the tests, and there we go. We have all of our constructors generated now by our Lombok annotations. But what else can we do to improve this class? Well, if we scroll down to the bottom here, one of the more elaborate methods is this toString method. Does Lombok give us a way to replace this? Absolutely does. Let me show you the toString annotation. So replacing our toString method with a Lombok generated toString method is very, very simple. So the toString method is overridden from the Java object class, right? So if we were to remove it entirely from our author there and then click on our tests, we'll see that we've got some failed tests. We don't have a compilation error because it's just going to use the object implementation. And we can see here that we've got author @ and then some memory address. That's no good. We want a nice helpful one. So we're going to go back to our author class, go back to the top of the class here, and I'm going to say @toString. Running our tests once more, and everything passes absolutely fine. So let's go over to the book class here. We'll right click, we'll go refactor, go down to our Lombok refactor tools, and we're going to use a default toString. There's our toString annotation. Let's run our test once more. Everything's passing, easy as that. So these classes are starting to look a lot cleaner, but we still do have this equals method and this HashCode method, and it's pretty ugly. This is the one that was generated from our IDE. So what can we do to replace this? You guessed it. Let me show you the equals and HashCode annotation. So here we are in our author class. So if we scroll down here, we can see that we've got an equals and a HashCode. If we remove these, we'll get some failing tests. Again, equals and HashCode comes from the Java top level object class. So deleting these and then running our tests, means that we get some failures because it would then try and compare based on things like memory addresses and stuff, which might be helpful, isn't in this case. So what can we do to fix this? Well, we can use a generated one, a Lombok generated equals and hashcode. Then running the tests, you can see that they all pass, easy as that. So let's do the same for the book class here. So let's go over, right click, we'll go to our refactor tools, scroll down, Lombok, default equals and hashcode. And there we go. There's our equals and hashcode. This class is looking a lot cleaner. Play all of our tests once more, and they all pass. So I think we can all agree that having 3 instance variables in a class is a lot nicer, a lot cleaner than having all of this boilerplate code in there. But that is a lot of annotations. Is there a way of maybe reducing the amount of annotations that we have? There absolutely is. Let me show you the @data annotation. Creating classes in Java to model and contain data is a really common pattern. DTOs or data transfer objects, great example of that pattern in action. Now we can see here we've used Lombok to really create a DTO for us. And we can see that we don't really have a lot of boilerplate code in this class, but we do have a lot of annotations. Well, there is the @data annotation. And what that's going to allow us to do is to remove the @getter, @setter, toString, equals and hashcode annotations. It contains them all. So what I'm going to do here is type @data and then remove toString, equals and hashcode, and then getter and setter from each of these instance variables here. And we can see we now have a 20-line class, including a comment. So let's just run these tests to make sure everything's working fine. Wonderful stuff. So let's do the same to our book class here. So we're going to remove equals and hashcode, toString, setter, getter, and then put @data on the top here. Run our test once more. And there we go. That is a very clean class to model a book object. So we've been focusing on the data structure side of things so far, but there are some other features inside of Lombok which are very, very handy. One of them is @log. So we've all logged in Java, right? I mean, we can do it the raw way of just doing a system.out.println, or we can do it the more refined way by using an actual logger, but creating an actual logger can be quite cumbersome. So let me show you how you can replace all of that with just a very simple 3-letter annotation, excluding the @. So let me show you @log. So we're going to go to somewhere that we're already doing a type of logging. So we're going to go to our app here, and we can see that we've got system.out.println, just the bare bones way of doing logging. So there we go. I've created a logger for us. We've got here a final static logger called log, and we're doing logger.getLogger for this app. And we can now use this log down here to do log.info. So if we run our application again, we've replaced that system.out.println with these log statements here, log statement level info. There's our book, The Crystal Rose, year published, and there's our author information as well. But I don't know about you, but this just all seems a little cumbersome. So what can we do to replace it? Well, we'll go to the top of the class here, and I'm just going to type @log, importing that. And then we can remove that declaration, but you'll notice log is still available. We're not declaring it anywhere. Well, actually the @log is making that log variable available to us. So if we run the class once more, we can see we've got exactly the same output, but we're not declaring our log anywhere. It's just being done via the @log annotation. The builder pattern is cool, and in my opinion, it reads a lot nicer in the code as well, but it does have a big benefit to using this pattern. If we look here, we can see our test data util class, where we are creating an author and we're creating a book just so we can use that throughout our application. Now, if we were to go to our author, for example, here, and we were to create a new instance variable, I don't know, let's do a string, and it's going to be the author's favorite snack. But then if I try and run all of our tests again, we can see that we've got a compilation error. And the reason being that all args constructor is now expecting an additional argument. It's expecting the author's favorite snack. Now, when you do that on a larger code base, it can be a pain because you then need to go around everywhere that's using that all args constructor whether it's been automatically generated by Lombok or not, and you need to replace it. Now, in the case that you aren't using Lombok to generate your all-ask constructor, you can sometimes get 4, 5, 100 different constructors in your class because you're just adding a new one every single time that you add a new instance variable, because that way you don't have to update any of the code that's using the old one. Bit of an anti-pattern. So using the builder gets around that. If we were to, for example, go back to author here, and we're going to remove, in fact, I'm going to cut favorite snack, run our tests again just to make sure everything is working fine as it was before. Well, we're building fine. Let's run tests. Looking good. So this is how we generate a builder. We go to our class and we simply put @builder on the top of our class. We'll do it for author there, and I'm also going to do it for book as well. You'll notice that there is no extra additional code in here at all. So what does that actually do for us? Well, let me show you. We're going to go to our test data util here, and rather than do the all-ask constructor way of doing things, I'm going to do it a slightly different way. So we're going to go return author.builder, and then we can do .given name, which we know to be Aria, family name, which we know to be Montgomery, and then the age is 36. We then do .build, and let's get rid of that one. And we can see it's nice and fluid. And the thing with doing it this way is if we introduce a new instance variable to our author class, it won't break the builder. We would simply need to go to the builders and add a new line in the places that we want to populate data for that new instance variable. So I'm going to do the same for the book down here. Book.builder, .title, .year published, .author, and we'll create the test author, .build. Always remember to call .build at the end, and we'll return that. There we go. Run all of our tests now, and they all pass absolutely fine. Now, there are some places in the project that do use the all-ask constructor still, but if we were to go back to our author and we were to put in favorite snack as a string, try running again, we can see here that it's the constructor, the all-ask constructor in a different test that's failing. So let's just make that pass. Oh, and it's easy as that. So we can see that the builder in our test data util didn't require any changes whatsoever. So that's about it for the main features of Lombok, but there are a bunch of experimental features from Lombok as well. So what I'm going to do now is just take you on a whistle-stop tour of those experimental features. Bear in mind, I'm not recommending that you use any of these. They're highly controversial, and the arguments for and against them are documented on the Lombok website. Enough of that, let's get into it. So let's look at some of the more experimental features in Lombok. So here we are at the Lombok website. Look up here, we go to features, we've got stable and experimental. Now, stable contains all of the, stable features of Lombok, including the ones that I've demonstrated for you today. There are some other ones in here which I don't consider to be as exciting, but obviously take a look at this page if you are interested. Now, if you go down to experimental, on the other hand, we can see Lombok's experimental features. So we've got things like accessors, extension APIs, delegates, utility classes, helpers, all of this good stuff. Now, a lot of these are quite niche, and a lot of them have kind of a bit of a for and against on them. So if we go to accessors, for an example, they're all very well documented. We can see that it's experimental, and we can see it's experimental because this is accessors there to generate a more fluent API, and we'll put it onto our project that we were using just to kind of demonstrate it a little bit. But when you're using these, obviously do just weigh up the pros and the cons. There might be one in here that just solves your problem and it's amazing, but there might be one that just causes a bunch of bugs in production. You've been warned. So accessors, a more fluent API for getters and setters. We'll take a look at that. We're also going to take a look at field name constants, and that's there to basically expose your field names as static variables. If you're doing something a little bit reflection-y, maybe, that could be useful. And we've got at utility class, which is just a nice way of generating a utility class simply, without boilerplate code. And we happen to have one of these, so that should be useful to see. So let's take a look at accessors to begin with. It's at accessors, and we want to put this on a class by the look of things. So let's go back to our code. Here we are on author. So I'm going to put at accessors on here. Let's run our tests. Okay, everything's still passing fine. Okay, this said it's going to give us more of a fluent API. So we're going to do fluent equals true. And we have some failures now. And it's saying the method getGivenName is not available, cannot find symbol. And I imagine it's because rather than getGivenName, it's simply now GivenName. And instead of getFamilyName, it's now FamilyName. Let's go back to our author and say chain equals true. So that's the getters, but what about the setters? So we've got here set given name aria. Okay, great. That's just going to be given name, I believe. Perfect. Now, what if we were to do a chain? If I wanted to set given name and maybe, okay, we can do that. So we can also set the family name to, I think that was Montgomery. And it would set both of those things. So that's where the fluid comes in. Similar to the builder, I suppose, but different from the builder pattern. So that's accessors. So let's undo all of this. That's the project reset. Let's take a look at field name constants. So this is just going to expose the field names of our class as static variables. Yeah, why not? Let's do that. And then we'll take a look at the utility class. So at field name constants, on top of author, import that. Okay, has it broken anything? No, everything seems to be working fine. So let's go to our tests then. They're static, so we need to do the author class. We can do dot fields, and then we have our fields available. So, okay, that seems reasonable. So let's do system.out.println, and we'll say field for given name is, and we'll just run this one test by itself. Field for given name is given name. So if that's your jam, that could be useful for you. But I'm interested in looking at this utility class. So over here, a nice easy way of generating a utility class. Now we happen to have one of these and it has static methods in it. What's different? Well, we add utility class to the top here and we just add methods to it, just normal methods, and then it makes them static or something. Okay, let's go back to our project. Just going to reset this project. Run all those tests. Okay, we're all passing. That's looking good. Go over to our utility class here, and I'm going to add that utility class method to the top, import that. Now, I believe you don't do anything static now. So we're going to remove the static keywords. These are just public methods. We don't have any instance variables on here at all. We'll remove the constructor as well, because I'm pretty sure that's generated for us. Gets rid of the red underline. Okay, well, let's run our tests and see if everything's being picked up okay. Yeah, everything passes absolutely fine. So I suppose that saves you a little bit of boilerplate code. Fair enough. Maybe it's not so obvious it's a utility class anymore, but yeah, definitely save some characters. I can see why that one is in the experimental. Maybe in future that could be useful. I don't know. Up to you. And there we go for the rundown of the Lombok Java library. I think you can see now why I love this library so much and how it can make you a so much more effective Java developer. Now, if you want to see it in action, I use it in this tutorial here to build a REST API with Java and Spring Boot. We use it for some of the domain classes and sprinkled along for things like log as well. So I'll see you over there.